Molar conversions using dimensional analysis. There are questions to be answered when solving these problems of molar conversions. First off, how many grams, moles, or things are in the substance that we're talking about? You will always be given some information before converting. There are two conversion factors that you will be using in order to convert between units. Molar mass is one conversion factor, and Avogadro's number, which are both equivalent to 1 mole. In fraction form, there are 4 conversion factors you need to know when using dimensional analysis. 1 mole is equal to X number of grams, which are also equal to 6.02 times 10 to the 23rd things. Now notice the question mark. The question mark is basically saying that there are a variety of different numbers that can fill in that spot there, depending on the substance that we're talking about. Here's what it looks like in fraction form. Grams can be either on the top or bottom, and so can moles. Here's the second conversion factor, where Avogadro's number is on top and moles on the bottom, or vice versa. Again, both are equated to 1 mole. There's a roadmap that will help you out in determining where your starting and ending points are when solving problems. Information you need in order to make these conversions are the molar mass and Avogadro's number. Now, when solving from grams to moles, the information that you need is only the molar mass. And when solving from moles to particles, the information you need is Avogadro's number. You cannot make one leap from grams to particles. You always need to stop here at moles in order to convert between these two units. In order to get from grams to particles, it requires 2 jumps. Okay? And each jump requires a different conversion factor when setting up the problem. Here's a step-by-step method in order to solve the mole conversion problems. Easiest problems are when we're solving problems from grams to moles. The conversion factor is molar mass, and you set it up where moles are on top and grams are on the bottom. Another easier type of problem is moles to grams, where the conversion factor is the same, the molar mass, but the only difference is grams are on the top and moles are on the bottom. Info that you need to solve this problem. These problems are the molar mass. Here's a practice problem. So, how many grams are in 13.4 moles of water? Well, in order to solve this problem, we need to know the molar mass of water, which is 18 grams, and notice how we put it over 1 mole. The reason we do that is when we solve the problem, when we multiply through using dimensional analysis, moles cancel out. When we do that, we simply are left with 241 grams of water. Notice how I'm abiding by the significant figures rule, where I start off with 3 significant figures, and I'm ending up with 3 sig figs in my answer. Here's another problem. How many moles are in a sample of 18 grams of calcium chloride? Again, the information that I need is the molar mass of calcium chloride, so I need to know my nomenclature. I need to know how to solve that using the formula. When I do that, I get 110.98 grams, which is equivalent to 1 mole of calcium chloride. And notice how I put the grams on the bottom and moles are left on top. And when I solve this problem, I get 0.162 moles of calcium chloride. Again, abiding by the significant figures rule, where I start off with 3 and I end up with 3. Here's some more easier type problems. When I'm given moles and I need to solve for atoms, my conversion factor is Avogadro's number. and I set it up where Avogadro's number is on top because that's what I'm looking for, and moles are on the bottom. Same type of deal, just the converse of that. When I'm solving for atoms and molecules and I'm trying to convert those to moles, my conversion factor again is Avogadro's number. I set it up where moles are on top, again because that's what I'm looking for, and Avogadro's number is on the bottom. Info that I need in order to solve these problems is, again, Avogadro's number. Here's a practice problem. So if there are 9.04 times 10 to the 23rd molecules of magnesium sulfide, then how many moles are in this sample? So I start off with this. Notice how I have Avogadro's number on the bottom because the molecules are going to cancel out, and 1 mole is on top because that's what I'm looking for. When I do that, I get 1.50 moles of magnesium sulfide. Here's another problem. If a sample of chromium 2 chloride has 5.07 moles, then how many molecules are in the sample? Again, I start off with my given information, which was 5.07 moles. Put that on the starting point and put 1 mole on the bottom so that they cancel out. And when I do that, I get this as my answer. Again, abiding by significant figure rules. The harder type problems are the two-step problems where you are given grams and you need to solve for atoms or molecules. You set it up using the conversion box where you solve for moles first. So moles are going to be on the top, grams are going to be on the bottom. And once you have solved for moles, then you set up a second conversion box and solve for atoms using Avogadro's number, where Avogadro's number is going to be on the top and moles are going to be on the bottom. Conversely, if we have atoms and molecules and we want to know how many grams are in our sample, then we just set up the conversion box and solve for moles first using Avogadro's number. And then once we have solved for moles, then we set up a conversion box solving for grams using the molar mass of that substance. Info that you need in order to solve these problems, it takes 2 steps. So therefore, there's 2 conversion factors. You need to solve for the molar mass and obviously know the Avogadro's number.